this is just the packet 1 summary review about the vectors. So very fast explanation about how you should have solved those kind of problems. The packet is this one. And for example, the first question says you have the component of those of the vector A, and they want to know magnitude of the vector. So what you do, this is your AX, which I drew right here. This is your AY, which I drew right here. They want to know the magnitude of your vector. Obviously, you have the two components. Now remember, guys, that the coolness of those vectors is that you can take the component, drag it on the other side, and then here you have your rectangle, your right triangle, and of which your vector is going to be the hypotenuse. So at that point, just because you're that cool and you know Pythagorean theorem, that's what you do to calculate the magnitude of the vector. Remember to maintain your sigfigs. So in this case, 18.5 is your answer. So 18.5C is your answer. Now for question number 2, again, you have components and they want to know this time the angle. So if you're looking for the angle, so this is the problem. They are saying though, they are stating that they want to know the angle that goes from the positive x direction. So this is your positive x direction. If you draw actually those two components, which are the ones that they gave you, you see that your vector is down there. So the angle that they are inquiring about is going to be the big angle, which is the 360 minus this little angle there. So that's what I did. I personally enjoyed calculate this angle here by doing the slope over the slope of your curve there. So your rise over run. So your AY over AX, because I know already where the vector is, I don't care about the sign there. So I do my rise over run, right, the Y over X. I find this number here, which is better being smaller, but whatever. So I find this number there. At that point, I do the tangent of the value, and I find 40 degrees. But 40 degrees, again, is this angle here. So you got to do instead your 360 minus the 40 degrees, and 320 is your answer for the second question. 320, so A. And then for the problem number 3, again, you have been given vectors, components for A and B. They want to know the magnitude of the sum of A plus B. So the way I do it, I copy it again. So this is the vector A, 5.1 and negative 5. That's the vector B, right? The 2.6, negative 2.6 and negative 4.3. You got to do A plus B, so I just add those components and I have the CX component, the CY component, and then I calculate the magnitude by squaring, and square rooting. So 9.6 is your answer, so D is that one. Then for number 4 says, okay, here you have this picture there. You have vector A, you have the magnitude of it, you got your angle, and they want to know components of A. Well, that's super easy because you take your A. So the component along X is going to be your 8.6 cosine, because that's your angle there. So cosine is this one, and your Y component is going to be your sine. So if you do everything like you should, cosine and sine, so A is going to be your answer. Then for number 5, again, you got those two vectors, and they say find the magnitude of A minus B. So it's not this vector here, but it's the one that has the minus. So to be minus, this means that this component is positive, so you got to have the negative instead. And this component is negative, you got to have a positive instead. So this means that the negative B is going to be here, right? So at that point, what you can do easily is to, again, write down your A. Instead of B, you write the minus B. So again, you're reversing this one. Instead of being positive, you make it negative. Instead of this one being negative, you make it positive, right? So you calculate your components for the CX and CY at that point, and then you do the square rooted, and you find your answer D for number 5. for number 6, they say find the dot product of those two vectors. Now, remember the difference between, we barely talked about the cross product, but we definitely talked about the dot product. Now, dot product is the product that you obtain when you multiply two vectors, and that answer actually is a scalar, as you can see. Okay, it's not a vector, it's just a scalar, and you obtain this number by doing your component, your magnitude of A times the magnitude of B times the cosine of the angle between those two vectors. So that's exactly what I said. So magnitude of A, magnitude of B, and cosine of your angle. So this is one way of solving it, right? According to what you have, or if you have both components, then you do the x components multiplied together, and you add the y components multiplied together. And obviously, if you have z components, you do the same thing, a z, b, z multiplied together. So according to this value here, they gave you basically those two components, so you don't have the angle between. So that's the way of solving for your dot product. And C is your answer. Okay. Then for the 7, you have two vectors given in this form. And remember, I, j, and k are the two versors of your vector. So this means that this minus 2 is in the I, so it's multiplied by the versor I, which means it's the vector of unitary magnitude along x. So this minus 2 means that this component is along x in the negative direction, because you have the negative there. This is negative 5j, so again j is the versor, so the unitary magnitude vector along y, and k is the same thing along z. So this means you have a minus 2 in the x direction, minus 5 in the y, and plus 2 in the z, and same thing for this one. So you have the components between of those two vectors. They want to know the angle between those two vectors. So what you can do is calculate the magnitude of the first one, the magnitude of the second one, and you will find those two magnitudes. Also, you know that another way of solving this, right, is by multiplying those two components together. So the x components, the y components, the z components. So now this side here will give you the a dot b using this formula. This side instead is still a dot b using this formula, right? So you put one equal to the other, and you solve for cosine of alpha. And this is your answer, okay? So 67 degrees. So B. And then 8. Number 8 tells you that you have those components, okay, and you got to calculate B minus A. So B minus A. And so instead of writing A, I'm changing those signs. So I have a positive instead of the negative, and negative instead of the positive, and basically at this point I add them up, because it's minus A plus B. So that's exactly what they are asking for, and you calculate at that point the magnitude of C, which is again square, square, and square rooted, and you find this answer here for number 8. For number 9, now they say the angle measured from the x-axis to vector C in degrees is closest to. So if you have gone that far, okay, you also know the Cx and Cy, so you know the magnitude of C. You know the two components, so basically you only need the two components to calculate the angle between them. So you do your y over x, you find the 0.36, you do the inverse inverse tangent, and you have a 20 degrees. Then number 10, you have vector z. You have the two components, find the magnitude. That's their point is super easy, right? Square, square, square rooted. Number 11, for number 11, you have, what are those? You have this vector q and you have the two components. What is the measure of the angle? Well, again, you have already the components. You do the x over the y over z, y over x. You find the value there. You do the intangent of it, and that's your answer for the angle. Number 12, you have two vectors now. Those are the two components of u. Those are the two components for v. They want to know u plus v. So again, you add the x and y. So you do that. And at that point, once you have those two components, so when you add those two, you have a 2.1. You add those two, you have a 13.5 square rooted, and you find the answer. Now 13 instead is more conceptual than calculation. Which of the following statement is true? Now, is a scalar quantity can be added to a vector? Well, obviously not, because when you add, don't forget that you always add stuff that are alike, right? That are alike. So, for example, that's what I wrote. A scalar can be multiplied by a vector. So when you multiply 2 times, for example, a vector that has those two components, right? You make this vector twice longer. So you can multiply a scalar by a vector, because that way you make it shorter or you make it longer. But you cannot add them up. You can add one student and another student. You have two students, but you don't add one student and one apple, because you still have one student and one apple. You cannot add stuff that are different from each other. They don't belong in the same category. And then it is possible for magnitude of a vector to be equal even though one of its component is not zero. I mean, equal to zero, even though one is not equal to zero. Well, no, it's not possible, because if you have a vector and has only one component, for example, right, and the x and y, for example, are zero, but the z is not zero, that particular magnitude of that particular vector is definitely not zero, because that means just is a vector that lies on the z-axis. So no, it's not possible. And then C, scalar quantities are path dependent while vectors are not. And this is actually true, because if you remember when you have a point, starting point and ending point, you can follow different patterns, right? Different paths, but the resultant of those paths is still the vector AB. So the vector doesn't change. The value is not path dependent. So that is true. And then you have scalar quantities and vector quantities can both be added algebraically. We just said no, because it's the same thing as before. And a scalar contains magnitude and direction. No, that's definition of vector and of scalars. So 13, your answer is C. Then for those next questions, you got to use those two vectors there. So that product between those two vectors, again, you have the component of A and components of B, so you just multiply this plus multiplication of this plus multiplication of this, and you get your final answer there. So you just multiply those. So 3 times 2 is 6, 18, 5, and that's it. So your answer is D. And then number 15, you have now the difference between, so not the dot product, but you got to do the difference between those two and tell which one it is. So, and that's the reason why I wrote it this way, because I knew that was referring to the same vectors for those questions 14, 15. So at this point, instead, you got to do A minus B. So A minus B. So this means minus B means this one is a positive. This one is a negative, so that's the negative. This is negative, that's the negative. And at that point, you just solve the inside parentheses, and this is the sum of A minus B.